Okay, for your WSQ tonight, we're going to be, again, looking at angles of elevation and depression in relation to trigonometric functions. So an angle of elevation is what we'll start with. Again, you can see that many real-world problems involve these. So if we have an example where we have a person who's looking up at something where their line of sight is increasing, basically we're going to look at that line in here as an angle of elevation. Again, you're looking up, something is elevated when it's up, so the line of sight is up, creating this angle of elevation on the side. So when I talk about angle of elevation, again, I'm talking about looking up at something. Okay? A little bit differently, when somebody's looking down, that's an angle of depression. An easy way to remember that, depression, literally all depression means is down. So if you have a horizontal line, that horizontal line is going to come in handy here a little bit when we do some practice problems. But when we have that horizontal line, the angle of depression is between the line of sight and that horizontal line. So notice it's not actually in the angle, so it's actually not in this piece in here. It's actually the line above it in here, okay, which is our angle of depression. Okay, and I'll show you some example problems that can become a little bit confusing. It's not actually inside the triangle, but it's the line in between the horizontal line and the line of sight. Okay, so let's try an example problem, and you'll notice these are pretty much just going to be word problems. So the best way to approach these is just draw a picture, draw a sketch, see if you can identify, number one, if you have an angle of depression, angle of elevation. Sometimes the problem will tell you. So the first part, the angle of elevation, okay, so we're looking up, from point A to the top of a cliff is 34 degrees. If point A is 1,000 feet from the base of the cliff, we want to know how tall the cliff is, okay, or how big it is. So this one is actually going to be pretty straightforward. So let's just draw a picture of this and see what this would look like. So again, we have a few things to kind of highlight here. Elevation. Okay, we have an elevation problem. Want to make sure to have that part we're looking up. Okay, the elevation is going to be 34 degrees. Point A is 1,000 feet from the base of the cliff. We want to know how high is the cliff. Okay, I think we got a pretty good idea now of what's going on. So here's point A. Okay, let me get out of my highlighter mode. Okay, so A to the top, this angle of elevation is going to be 34 degrees. So in other words, right in here, that angle is 34 degrees. Notice I'm basically just creating a right triangle out of this. Okay. We also know from point A to the base of the cliff is 1,000 feet. And this is where the edge of the cliff is right here. Okay. And if we had earlier, we had our little horizontal line in there, but this is the cliff right there. We want to know how high the cliff is. So in other words, x. So now we just use our trig functions. Everything's set up for us. We have from this angle, a side opposite, a side adjacent. So we can use our tan ratio. So again, we'll go ahead and write out tan 34 equals opposite over adjacent. We're going to be multiplying. Okay, tan of 34 times 1,000. Okay, and again, you'll need to get into Desmos or use your scientific calculator. Make sure you're in degrees. Okay, but again, basically it's x is equal to tan of 34 times 1,000. We can go ahead and multiply those. X is going to be approximately 674.5 feet. Okay? And that's how we would solve that problem using an angle of elevation. Okay, let's go and try depression on the next one. Okay, so now here's a good angle of depression problem. So we have a ski run, okay, that is 1,000 yards long, and it has a vertical drop of 208 yards. We want to find the angle of depression from the top of the ski run to the bottom. So again, we have ski run 1,000 yards long, vertical drop of 208 yards, and we want to find the angle of depression from the top of the ski run to the bottom. So one of the biggest things to keep in mind, and one part that can be the most confusing, is, remember, this angle of depression is horizontal. Okay, it's created with that horizontal line. So basically, if I write in here an angle, this is the angle of depression. Okay. Again, we're going to have a triangle in here. Okay. But just to keep in mind, this is not the angle of depression. This is. It's between the line of sight, okay, which is here. It's the hypotenuse, basically, is your line of sight, and that horizontal line. Okay. That's what we're calculating, is this little angle right in there. Now we know a few things. The ski run is 1,000 yards long. So think about it. If you're skiing, you're going to start at the top and you're going to ski down this entire side of the mountain. Well, that's 1,000 yards long. Okay, that's what you're skiing. Okay. We also know it has a vertical drop of 208 yards. So in other words, you're going to start at the top of the mountain and you're going to decrease 208 feet. So in other words, this length here is 208. Actually, it was yards. I think I said feet. Okay, but that's 208 yards. We want to find that angle of depression at the top. Well, to do that, you first are going to need to calculate this angle. Okay, and we do that by using cosine ratio. Okay, and actually it's going to be arc cosine, okay, or inverse cosine. But we have, from relation to this angle, a side adjacent and a hypotenuse, which that's definitely using SOHCAHTOA. That's our cosine. Okay, the CAH. So cosine and of that angle, we don't know, equals adjacent over hypotenuse, which is the line of sight. So 208 divided by 1,000. Again, we want to type that in Desmos. We are using inverse, so if you're using Desmos, it's arc cosine. If you're not using Desmos, it's cosine to the negative first power. Okay, it's just the inverse. So let's go and type that in. After you do that, you're going to find that that's going to be equal to about 78 degrees. However, keep in mind, that's this angle. Okay, that is not the angle of depression. The angle of depression is inside here. So how do we get that? Well, notice this horizontal line is parallel to the bottom, meaning there's a right angle here as well. So long story short, you're going to subtract 90 from 78, which is 12 degrees. So the angle of depression, 12 degrees. Okay, so what I want to see if you can do, go ahead and see if we can pause the video, and I want you to find the angle of elevation of the sun when a 12.5 meter tall telephone pole casts an 18 meter long shadow. I will obviously go over it with you and show you how to do it, but see if you can try it right now by pausing the video and working it out. Okay, so let's go ahead and try it out. So again, we want the angle of elevation. So in other words, angle of elevation looking up. And in this case, here's the sun. Okay, it's the angle of elevation of that sun with a pole right here. So we have a pole that's 12.5 feet, actually meters, okay, tall. There's our little pole, telephone pole. We also know that the shadow is 18 meters long. Again, I want to find the angle of elevation, which is formed in here. Okay, so we don't have to do any work with our horizontal line. Again, the horizontal line is still parallel, okay, to that base, even though that doesn't look too parallel. Okay, but it's still parallel to the bottom down there with the shadow. Let's go ahead and calculate what this would be. So we figure out our ratio from that angle. We have a side opposite, got our adjacent. So I'm still going to use tan. And we want to make sure to set up the tangent of opposite 12.5 over 18 adjacent, and we just type it in, okay, using our calculator. So we can go ahead and put arc tan 12.5 divided by 18, which is about, looks like 34.77. We'll go ahead and round it to about 35 degrees. And that is the angle of elevation right in here. One, we want to go ahead and find From the top of a 120-foot high tower, an air traffic controller observed an airplane on the runway at an angle of depression of 19. Again, right when you see angle of depression, think about your horizontal line at the top. Okay, you're going to be looking down. Depression, right, means down. So you're going to be looking down this way with this angle of depression as 19. Okay, so we don't really even know too much else in that problem, but that's exactly what I do know. The angle of depression is 19 degrees. We also know from the top of a 120-foot tall tower. So here's what else we know. 120 feet tall. Okay, an air traffic controller observed an airplane on the runway. Okay, so here's a little airplane down here. Okay, how far from the base of the tower is the airplane? So in other words, I don't want to know this distance right in here. We don't know. So we can use a ratio. Again, all we have is an angle of depression. That doesn't mean that's with the hypotenuse or adjacent or anything else. So we need to figure out first this angle before we move on. And again, how do we do that? Well, we take 90, subtract 19. That angle is 71 degrees. Okay, so now I have a side adjacent, have a side opposite. Now we can use our tan ratio, and we're going to use tan of 71 equals opposite over adjacent. We're going to be multiplying tan 71 times 120, and you should get x is about 348.5 feet. Okay. So again, the angles of depression, elevation, they can be a little bit tricky, okay, especially the angles of elevation. But we'll practice this in class a little bit more tomorrow. So please go ahead and fill out your discussion for tonight. Make sure you get your 10 points. And then I will see you tomorrow. And again, like I said, we'll practice this a little bit more. Have a good night.